In this lecture, we're going to talk about solving triangles of the general form using the law of cosines. The law of cosines is as follows. For any triangle ABC, the following equations hold. A squared equals b squared plus c squared minus 2bc times the cosine of A. B squared equals a squared plus c squared minus 2ac times the cosine of B. And c squared equals a squared plus b squared minus 2ab times the cosine of c. So in general, when you're solving a triangle, you'll be given three pieces of information. So find the equation that has the three pieces that are given and use that equation to find the fourth piece. We can use the law of cosines to solve the following types of triangles. Side angle side, where we know two sides and the angle which they make, or the included angle, or side side side, where we know all three sides of the triangle. All right, so basically, if you have a triangle and you don't know a side and the angle across from it, you can't use the law of sines. And if you can't use the law of sines, you can usually use the law of cosines. So let's do an example where we're going to solve a side angle side triangle. We want to solve the triangle that has side C of length 15, side A of length 12, and angle B of measure 133 degrees. So since we're given side A, side C, and angle B, we're going to use the form of the law of cosines that have those three values, side A, side C, and angle B in them. And so that would be the second form from the previous slide. B squared equals A squared plus C squared minus 2AC cosine of B. And we'll use this to find out what side B is. So we plug in the information that we know. That's going to give us B squared equals 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 133 degrees. We can simplify a little bit using our calculator. 12 squared plus 15 squared will give us 369, and 2 times 12 times 15 times the cosine of 133 degrees will give us negative 245.51. So this simplifies to be b squared equals 369 minus a negative 245.51. If we simplify further by putting those together, we'll get b squared equals 614.51. And if we take the square root of both sides, we'll get that b is approximately 25. So next we want to find the measure of angle A. Now, since we know side B and angle B, we could switch over and start using the law of sines here, but since this lecture is about the law of cosines, we're going to keep using the law of cosines for this example. So to find the measure of angle A, we're going to use the form of the law of cosines that has angle A in it. That's A squared equals B squared plus C squared minus 2BC cosine of A. And we'll plug in the values that we know. So 12 squared equals 25 squared plus 15 squared minus 2 times 25 times 15 times the cosine of A. If we simplify a little bit, 12 squared is 144. 25 squared plus 15 squared will give us 850. And 2 times 25 times 15 gives us 750. So we get 144 equals 850 minus 750 cosine of A. If we subtract 850 from both sides of the equation, we'll get negative 706 equals negative 750 cosine of A. To get the cosine of A by itself, we'll divide both sides by negative 750. So negative 706 divided by negative 750 equals the cosine of A. And then to solve for A, we'll take the inverse cosine of both sides. So A equals the inverse cosine of 0.9413. And if we evaluate that with our calculator, we'll get that the measure of angle A is approximately 20 degrees. And so the last thing that we need to do is find the measure of angle C. So we'll use the fact that three angles in a triangle add to be 180 degrees. That means that C will equal 180 degrees minus 133 degrees minus 20 degrees. And if we evaluate that, we'll get C is about 27 degrees. All right, next we want to look at an example where we try to solve a side-side-side triangle. So, solve the triangle with side A equals 2, B equals 3, and C equals 8. Since we're given the measure of all three sides, A, B, and C, we can really use any of the forms of the law of cosines because all three forms have A, B, and C in them. It really depends on which angle we want to find. So let's start by trying to find angle A. To find angle A, we'll use the form of the law of cosines. A squared equals B squared plus C squared minus 2BC cosine of A. If we plug in the values that we know, that's going to give us 2 squared equals 3 squared plus 8 squared minus 2 times 3 times 8 times the cosine of A. If we simplify these terms, 2 squared gives us 4 on the left-hand side. 3 squared plus 8 squared will give us 73. And 3 times 2 times 8 will give us 48. So 4 equals 73 minus 48 cosine of A. We subtract 73 from both sides of the equation, giving us negative 69 equals negative 48 cosine of A. We'll divide both sides by negative 48 to get cosine of A by itself. So cosine of A will equal negative 69 over negative 48. 69 divided by 48 gives us 1.4375. And so to find A, we take the inverse cosine of both sides. So A equals the inverse cosine of 1.4375. And if we put that in our calculator, we're going to get an input error, and so this has no solution. And this is because the cosine function only goes from negative 1 to positive 1. So if you try to take the inverse cosine of something bigger than 1, or the inverse cosine of something less than negative 1, it doesn't exist. So there are no triangles that satisfy these criteria. Let's do one last example where we look at a side-side-side triangle. So we want to solve the given triangle if side A equals 11.2, side B equals 5.4, and side C equals 7. Now again, since all three versions of the law of cosines deal with A, B, and C, we can really pick any one that we want depending on what we want to find. So let's start by finding capital A. To find the measure of angle A, we'll use the formula A squared equals B squared plus C squared minus 2BC times the cosine of A. If we plug in the values that we know, that'll give us 11.2 squared equals 5.4 squared plus 7 squared minus 2 times 5.4 times 7 times the cosine of A. If we evaluate those, 11.2 squared gives us 125.44. 5.4 squared plus 7 squared gives us 78.16, and minus 2 times 5.4 times 7 will give us a minus 75.6 cosine of A. If we subtract 78.16 from both sides of the equation, we'll get 47.28 equals negative 75.6 cosine of A. Then we divide both sides by negative 75.6 to get cosine of A equals 47.28 divided by negative 75.6. 47.28 divided by negative 75.6 will give us a negative 0.6254. And to find A, we'll take the inverse cosine of that. And so if we evaluate that with our calculator, we'll get A is approximately 128.71 degrees. Next, we'll find the measure of angle B. To find the measure of angle B, we could switch over and start using the law of sines, but if we're going to use the information that was given to us, we can stick with the law of cosines. So to find angle B, we'll use B squared equals A squared plus C squared minus 2AC cosine of B. If we plug in the values that we know, we'll get 5.4 squared equals 11.2 squared plus 7 squared minus 2 times 11.2 times 7 times the cosine of B. If we simplify those, 5.4 squared is 29.16. 11.2 squared plus 7 squared gives us 174.44. And 2 times 11.2 times 7 will give us a minus 156.8 times the cosine of B. We subtract 174.44 from both sides of the equation, giving us negative 145.28 equals negative 156.8 cosine of B. Then we divide both sides of the equation by negative 156.8. Negative 145.28 divided by negative 156.8 gives us 0.9265. And to find B, we'll take the inverse cosine of that. If we put that in our calculator, we're going to get that B is approximately 22.1 degrees. So the last piece of information that we need to find in order to complete this triangle is the measure of angle C. And since we know the measures of angles A and B, We can use the fact that they should all three add to give us 180. So C will be approximately 180 degrees minus 128.71 degrees minus 22.10 degrees. And if we evaluate that, that's going to give us approximately 29.19 degrees. So now we've completely solved this triangle.